So if the hydrated ion size is larger than the second ion, now let's consider in the case of lithium and cesium, as you can see on your screen, cesium being the higher size or being with the bigger size will attract lesser H2O, but lithium with the smaller size will attract more H2O. Now the size of hydrated ion will be greater in the case of lithium and will be the smaller in the case of cesium. Now let's suppose when we talk about mobility, let's take an example. Suppose you are a runner, or let's consider two simple human beings. One has weight of 50 kg, another has weight of 100 kg. Now they are both not athletes, they are just normal human beings. Let's consider that when the 50 kg weight man starts running with comparison to 100 kg, you tell me which will have the higher speed, or let's say which one will have the higher mobility. Obviously the one which has lesser weight, that is 50 kg person, will outrun the 100 kg person unless and until that 100 kg is not an athlete person, correct? So same thing happens over here. The size of hydrated ion plays an important role to identify mobility. So if the size of hydrated ion is the more, obviously the mobility, the speed will be less as compared to the other ion which has lesser hydrated ion. So if the size of hydrated ion is more, the mobility will be less. If the size of hydration ion is less, the mobility is more. I hope you are clear with this. Let's move on to the next concept. Now let's understand with example. In the case of lithium, sodium, potassium, rubidium and cesium. So you tell me now which one will have the higher hydration. Now lithium will be having the least. Why so? Lithium with the smallest gaseous atom will attract more H2O molecule from the solvent, so the hydrated ion size will be greater in the case of lithium when compared to the sodium, which will have the little bit less size than lithium, correct? So lithium will be having more hydrated size. Sodium, as compared to, which is larger in the size than lithium, will have little bit less hydrated ion size. So when we compare this among the group 1, cesium will be having the highest hydration. Why? Because cesium is the largest in the size, will attract the fewer H2O molecule. Hence the hydrated molecule will be smaller in the size. So smaller is the size of hydrated molecule, greater will be the mobility. Hence the order is something like this. Your cesium being the largest atom and the smallest hydrated ion have the highest mobility. Then comes your rubidium, then comes your potassium, then comes your sodium, and then comes your lithium plus 1 in the case of mobility. I hope this is very clear to you after this example. So as the mobility of ion increases, obviously the conductance of the solution will increase. So conductance of alkali metal also increases, like your cesium will be the highest, your rubidium comes after cesium, then potassium, then sodium, and then lithium. So we have discussed about mobility and conductance. So more the mobility, more will be the conductance. So cesium being the largest ion, or the, we can say cesium will be the highest molecule. So cesium being the largest atom will attract fewer H2O molecules. So the hydrated molecule size will be less, the hydrated ion size will be less. So your cesium will be the highest mobility, hence the conductance of the cesium will also be the highest, and the lithium conductance will be the lowest, because the hydrated molecule of lithium or hydrated ion of the lithium will be the largest, hence the least mobility. I hope this is very clear to you and there is no confusion in this.